Halloween, ich bringe Ihnen hier Birmingham, die 4312. Und geben Sie mir bitte hinterher die...
The international exchange connects London with the cities of Europe. Each of these tickets is a demand for a telephone call from England to the continent. And every call must pass through the network of submarine cables on the bed of the English Channel.
Double 15799. Mr. Eppendorf.
7 Palace 0011. K like King, like T like Tripoli, T like Casablanca.
Hallo Marseille.
Baby Baltimore 27437. Barcelona 78613. Barcelona 78613.
580-840.
If one of the cables goes dead, the others become overloaded. It's important, therefore, to keep all the lines going. So frequent routine tests are made. When a fault is discovered, the engineers calculate its position and a post office cable ship puts to sea to repair it. The ship steams to sea along the charted course of the cable. The shore engineers have told the captain roughly where the fault is, but before he grapples up the cable, he must know its exact location. This is how it's done. 2 electrodes are paid out over the stern and towed in the wake of the ship. From the shore, an electric current is passed out along the cable. When the current reaches the fault, it leaks out and returns to the shore, partly through the seawater and partly along the outer armoring of the cable. The electrodes pick up the current returning through the water. By means of sensitive apparatus in the ship, the difference in voltage between the electrodes is registered on a galvanometer. This voltage is greatest when the electrodes are directly above the cable. But when the ship has passed beyond the fault, the electrodes can pick up no more current, and the galvanometer gives no more readings. This method tells the captain exactly when the ship has arrived above the fault, and at the same time gives him a check on the course of the cable. The navigating officer sets a zigzag course to and fro above the cable. The greater the angle at which the electrodes cross the cable, the clearer the galvanometer readings will be. Meanwhile, a buoy is prepared to mark the exact position of the fault. Suddenly, the galvanometer begins to play tricks. It swings up to maximum deflection and then falls back to zero. The electrodes are picking up no more current. The ship has passed the fault.
Stand by, sir. Stop, stop. Let go, mushroom. Let go, master. Lift, boy.
"25 fathoms down, defective cable is lying on a sandy bottom, and down goes the spear point grapnel to drag for it. The chief officer, sitting on the grapnel hawser, can tell in a moment from the feel of it when the cable is hooked. As soon as the cable is passed under the bows, the crew take charge of it. The cable foreman will describe to you how they haul it inboard, and the jointer how he repairs the fault.
My first job is to get the cable inboard. The strain on the cable is too heavy to allow the bight to come in, so this man has to be lowered over the bows in a bosun's chair to secure the cable with chain. When the chains are secured, the cable is sawn through and one end is hove in. The other end is slacked away to avoid too much strain. Luck is with us. Here's the fault itself coming over the sheaves. And by the look of things, it has been fouled by some trawler's gear. When the fault has been hove in, the damaged part is cut out. Then we remove the outside sheathing and hand over to the jointer. He'll tell you how he makes the joints.
That's me on the left, starting work on the core of the cable. Running through the middle of the protective sheathings of the cable are the conductors, just like any roadside telephone wires. First, I strip off 2 inches of the gutta percha covering. Then I clean the conductors themselves carefully and tin them for soldering. Then I place the 2 ends in a vise so that they are lying flush. When these 2 ends have been run together, I bind the joint with number 30 gauge copper tin wire. Then I solder these protective stands together to give added strength to the joint. Now the faulty section of the conductors have been repaired, and England is once more connected with the continent. Now that the new joint has been made, I must see that each conductor is insulated. First, a dab of Chatterton's compound, then a warm sheet of gutta percha, worked in with the finger and thumb to force out the air and tool down. The core is now ready for the cable foreman again.
Now I have to make sure that the core is well protected. It is first covered with a paper felt tape, then brass tape, then jute yarn, all to protect the core. The sheathing wires are now brought up over the joints and an overlapping splice is made. When the outside arming wires are all in position, we put a wire lapping every 2 yards along the splice with a serving mallet. Then comes a serving of spun yarn over the whole length of the splice, and the job is done.
Half speed!
Half speed, sir.